Just like with mean values, we have a collection of formulas for proportion hypothesis test and confidence intervals. The two formulas are, for hypothesis test, we have Z is equal to this, which is pretty typical. This right here is your estimate, the proportion you computed. This one is the hypothesized proportion, and you'll notice that that is what gets used down here in the standard error, the quantity under the root. When we do the confidence interval, that changes to where we use p hats instead of p's, and we have a Z confidence interval critical number. So in this video, we're going to do the hypothesis test next, and then in the following video, we'll do the confidence interval. So let's just pop ahead. I've got a question ready to go. So here we see 37% of 100 people agreed with some survey question. We want to know, is this proportion significantly larger than the expected 25%? We'll use 1% level of significance to sort this out. So the null hypothesis will be that P is still 25%, while the alternative hypothesis, as given in the question, is that P is now greater than 25%. Alpha, the level of significance, we'll set at 1%. Our formula then is p hat minus p, all divided by the square root of p, 1 minus p, over n. Remember, this is your success condition, and the 1 minus p is your failure condition. Let's put the numbers in. So this is 0.37, and we'll subtract 0.25. Here will be 0.25 times 1 minus that, or 0.75, divided by 100, and that's under a square root. So our test statistic Z, it will be, in the numerator, 0.12, and when we use our calculator to find the denominator, we end up with 0.0433. And dividing those two numbers out will give us our test statistic. In this case, it's 2.77. Now, that's a positive value. And if I make a quick doodle of our typical bell curve, 2.77 is over here. And from the Z table, the p-value we get will be in this region. But of course, hypothesis tests are concerned with the tails. So this is what we want. We want this end. So we can either get that by going 1 minus whatever this number is, or I can look up negative 2.77, and that will give me the number we need here. So let's go take a look at a Z table and see what we find. So that's the T table. We'll flip over here to the Z table. So here's positive 2.7, and if we count across, this is 277, so we get 99.72. Were I to look at the negative value, you will find here is negative 2.7, and over here in the 7th column is 0.0028. If you add those two numbers together, they make 100%. Which they should, and that is our p-value, 0.0028, which is considerably smaller than the level of significance here. So that means we have evidence to reject the null hypothesis at the 1% level of significance. We'll look at the confidence interval using the same question values in the next video. This video ends here.